In this lesson, we are going to create the last of our utility nodes, which we will use to take our buildings to the next level by instancing our assets onto the faces of the proxy meshes that we created in the previous lesson. Before we begin, however, I want to take a look at our assets. The way these are organized inside of the outliner is going to be extremely important. Let us just hide our main city for the moment. Inside our window sets collection, we have two sub-collections, one for residential and one for commercial. If we look inside the residential collection, we will see that it contains several sub-collections. Each of these sub-collections represents a specific stylistic set of assets. This setup ensures that each building can maintain a cohesive look throughout its design. For example, if we open Residential 3 and take a closer look, we will see multiple meshes inside. Let us turn off wireframe mode and zoom in. Each of these elements is different apart from the two wall elements, which are the same but otherwise. We have various assets we can use and distribute randomly across our buildings, but by ensuring that they still have the same look, it is going to look like the entire building belongs to the same stylistic choice, where we have these pillars that are separating each of the assets. Similar for 2. If we just expand this, and I am just going to move these over so that it will look like it might do if these were all instanced together. You can see on this portion we have our bricks, and then a concrete stripe that runs along the top of each asset that will separate out the different floors. When these are all instanced on our buildings, they are going to look like they are all part of the same stylistic structure. However you build your assets, whatever assets you are using, whether or not you are using these assets from the source files, or whether or not you are building your own generator, this, I find, is the most optimum way of organizing our assets. Of course, they do not need to be meshes within the sub-collection. We could have these as multiple sub-collections like this, so that each of these sub-collections then becomes our individual assets. And we can make these as complicated or as simple as we would like. The main thing that we need to note, though, is that all of these have their origins in the dead center of the assets, and all of them should be cleared of any locations and be aligned to the world origin. So I am just going to press Alt-G to clear the locations of those. And I am going to do the same thing on these ones as well. Before we start instancing these, though, what I do want to do is to create a separate node group that I can use that will have the correct assets assigned to it. What I mean by this is that when we separate each of these items, it is going to be quite difficult for us to access these individual assets here as individual instances. Building, for instance, if we are focusing on this building here, And let us just put our wireframe back on, so we can see the faces. If we were looking at this building, and we wanted to say that this building is going to use assets from this residential 0 collection, and that each of these faces is going to use one of the assets from one of these objects here. Well, that means that we would have to separate out this collection and have these individual meshes as instances that we can then pick from. But we do not want to do that manually. We need to make sure that this setup works entirely procedurally and randomly, so that we can control it using a seed value. So instead of this building using residential 0, we could change the seed and have it use residential 5, with all of those specific assets used for its windows. To do that, let us start by bringing our full residential collection into the node tree. For this step, we are going to need to focus more on the spreadsheet than on the 3D viewport. So I will make this a bit larger, since we are not going to rely on the 3D viewport much during this process. With Shift Control held, as we examine our instances, we can expand this area of the viewport. In this top section, which we have not looked at much so far, we can open the geometry tree dropdown. And this is something new in Blender 4.3. This feature now gives us dropdowns where we can browse through the contents, just like we would in the outliner. It is incredibly useful. And I am genuinely happy that Blender 4.3 includes this. It really makes a difference. What we are first going to want to do, though, is when we look at this and select the top level. This represents the geometry that is being sent directly into our viewer node. This is just a single instance, B-City window set residential. If we click on it, we can see all 5, or actually 6 elements within that collection. But we need to make those visible directly from the top level. To achieve this, I will use a realize instances, a node. When I drop it in, it converts everything into actual geometry vertices, faces, and other data. If we uncheck Realize All and inspect the spreadsheet, we will see that our instance count is still just 1. That is the full window set residential. But when I increase the depth, the realization happens 1 level deeper. Now we have 6 instances, which represent the 6 window subsets inside the collection. Now let us use a separate geometry node. We will separate based on instance selection. To do that, I will use an equals node and connect the index. So when the index equals a specific number, that subset will be separated out. If we now look in the top left corner of the spreadsheet, we can see that we are isolating residential 0. And as I increase the number in the equals node, it updates. We go through 3, 4, 5, and so on. What I want next is to use a random value here, so that each building can pick a random set using a seed value. Now, if we look up in the top left corner, we can see that the collection residential 0 is being separated. When I increase the number in the equals node, we move through the sets 3, 4, 5, and so on. What I want is for this value to be random and controlled by a seed for each building. Let us add a random value. Node. We will set it to integer mode. The minimum will be 0. The maximum must match the highest index in our collection. In this case, since we have 6 instances, the maximum index is 5. Remember, indexing starts at 0, so we count from 0 to 5. Let us plug this random number into our equals node. Now, however, we are seeing 2 different instances being separated at once. Why is that? It is because each instance is receiving a different random number between 0 and 5. If we select both the realize instances and the random value node and inspect the result, we can see what is happening. Make sure that the viewer is set to instance. In the spreadsheet, we are now seeing a column showing the random value assigned to each instance. But oddly, we are getting multiple values instead of just one consistent number. What we want instead is for all instances within a building to receive the same random index. To do that, we will provide a single value into the ID input of the random value node. Let us use an integer input and connect it to the ID. Now, as we check the viewer, we will see that all instances are receiving the same number. Now we can see in the viewer that the random value being generated is consistent across all indices. When I change the seed value, we get a different random number, and that number is used for every instance uniformly. If I now look at the output of the separate geometry node and remove the viewer value node from the graph, we can clearly see in the top left corner that residential 5 is currently being separated. And by modifying the seed value again, we can switch to different subsets of our window collections. That is working great. Next, we need to access the individual items inside one of these subsets. To do that, we will again use a realize instances. A node. Uncheck realize all. And set the depth to 1. Now we are getting 5 instance. Is 1 for each window variant. This gives us the output that we can feed into an instance on points. A node. These now act as our instance source, which we will select from when instancing. Now, inside the instance on points, a node, there is a toggle called Pick Instance. And if you look at the tooltip, it says, choose instances from the instance input for each point instead of instancing the full geometry. So now we can plug a random value node into the instance index input, and it will randomly choose from the list of available window variations created from our realize instances node. So how do we generate the instance index? That is going to be another random value node. Again, we will set it to integer. The minimum will be 0, and the maximum should be 4, because we have 5 elements total. Since indexing starts at 0, we subtract 1 from the count. This will now act as our instance index. However, as with the earlier random value for selecting the window set, here we have a max of 5, and now a max of 4. We do not want to hard code those values. For example, let us say we are doing the same setup for doors. Inside our doors collection, we might have a similar structure. But under commercial, we only have a single asset in the commercial doors set. The same situation applies to windows. Residential windows contain 6 subsets, but commercial windows might only have 5. So we need a way to find that maximum value dynamically and procedurally. Whether we are dealing with sets or with individual items inside a set, we can do that using the domain size node. This node gives us a single integer based on the count of elements in a specific domain. If it is set to mesh, we can get vertex counts, edge counts, face counts, or corner counts. If it is set to curve, we can get how many points or splines there are. And if we set it to instance, we can retrieve the number of instances. We can get the number of points and splines, but what we need now is the count of instances. So I will set the domain size node to instance and connect it to the output of our first realize instances node. Now if we check the spreadsheet, we are getting an instance count of 6, which matches the number of window sets we saw earlier. To use that as the maximum for our random index, we need to subtract 1 from it since indices start at 0. So let us add a subtract, a node. Connect the instance count to the first input, and type 1 in the second. Now we are getting 5 perfect. Let us plug this value into the max socket of our first random value node. We can now delete the viewer node that was previously connected for inspection. We are going to do the same thing for the elements inside the window set. From our second realize instances node, I will drag out and add another domain size node, set it again to instance, and connect it. Add a subtract node, subtract 1 from the result, and plug that into the maximum input of our second random value node. This way, both maximums are calculated procedurally, no hard coding. Next, I am going to select everything from the collection info node up to the second random value, and press Ctrl G to put them into a node group. Inside the group, I will first expose the collection input from the collection info node by dragging it to the group input panel. Now I will select everything starting from the collection info node to the last random value node, and press Ctrl G to place all of this into a node group. Inside the group, the first thing I will do is drag the collection input from the collection info node into the group inputs. Next, I want to clear out any default values from the group socket inputs. That is important because if you later append this node group into a different Blender file, and it includes defaults like a specific collection, Blender might try to bring those assets into your clean scene, which is not something you usually want. Now, I will duplicate the group input node so we can add a few more parameters. We need to include the group ID, which is the integer we used for the first random value, the one selecting the window set. Then I will grab the seed input from that same node and rename it to setSeed. After that, I will go to the second random value, the one used for choosing the asset inside the set, and bring in its seed as well. I will call this element seed. Finally, I will press Ctrl H on these group inputs just to tidy things up a little bit. Let us tab out of the node group and scale the layout up a bit so we have more space to work with. I am going to name this node group Separate Elements. Now we have a utility group that allows us to select a collection. Assign a group ID, which corresponds to each building, as well as provide a seed for choosing the set, and another seed for picking an element inside that set. Let us now add those exposed values into our building settings. In the modifier panel, So I will add a new input and set it to integer. We will rename this one to building set seed. Keep it as a single value. I will now duplicate that field and rename the second one to window seed. Next, I will take the output of our separate elements. Node and connect the instance is output to the instance. Input of our instance on points, node. Then I will take the instance index, output, and plug that into the matching instance index, input. Just make sure that pick instance is enabled, so it knows to randomly pick from the list of instances, rather than using the whole geometry at once. Let us turn off wireframe view to get a better look. And even though this setup is not perfect yet, if we connect our building proxies directly into the instance on points, node, and view the result, we are already getting something that looks pretty decent. Of course, there are still several issues to address. For example, many of the windows are not aligned correctly. That is something we will need to fix. Also, right now, the group ID input is missing. So every building is getting the same seed for its window set. That is not ideal. In the next lesson, we will focus on fixing those alignment issues and making sure every building gets a properly assigned window set with good-looking positioning. That will make the buildings feel much more dynamic and believable.